Okay, today we're starting Module 4, Lesson 1. Module 4 is on expressions and equations. Now, I know Common Core has a reputation of being really difficult and really challenging. I know it's Friday, I'm kind of tired, but we can get through this. Today we're going to look at addition and subtraction. I know, yes, two. We're going to cover both of them in one day. All right, and we can do this. We're going to help each other, and we're going to get through this. It's going to be okay. All right. We're actually going to take another peek at tape diagrams way back from Module 1. So, shh. Pencils down. So, Part A in your notes asks you to draw a tape diagram to represent the following expression, 5 plus 4. So, 1, 2, come on, 3, 4, 5. So there's our 5. But they want us to add 4 more. So 1, 2, 3, 4. We okay so far? Now, let's just talk a minute about tape diagrams. What do we notice about all of the squares on that tape diagram? They're all equal. They're all the same size. That's because each box has the same, pencil should be down. That's because they all have the same what? They're all the same size because they have the same value. That's right. And in this case, in this tape diagram, what is the value of each square? What did we call that? When each box represented the same number. What was that called? Take a chance. Take a chance. What was it called? They're all 1. They're all the same number, the same value. The value is equal. That's not the vocabulary word. Oh. Come on. Constant. That's our constant. So in this tape diagram, our constant is 1. And we remember that our constant can change from expression to expression. Now here it said this is an expression, and here they're asking for an expression. But the title of this module was Expressions and Equations. So what's the difference between an expression and an equation? Well, let's look at 2 more expressions for Part B. This tape diagram, let's assume, because it doesn't tell us, so let's assume that again our constant is 1. So if our constant is 1, what is the expression for this first model? 2 plus 2. And what's the expression if our constant is 1? What's our expression for the bottom one? 3 plus 4. Now all of these are expressions. What would I have to do to make them equations? I'll give you a hint. That's your hint. What's the difference between an expression and an equation? So the expressions were 5 plus 4, 2 plus 2, 3 plus 4. What would we have to do to make them equations? We have to include the equal sign and the answer. So the equations have the equal sign and, in this case, the sum, or a product, a quotient, difference, okay? But today we're looking at expressions. They did not ask for equations, so that's why we didn't put the sums down, okay? Still with me? All right?
For sure.
Okay. Told you, stuff's, whew, for a Friday nonetheless. Come on, smartboard. Okay. All right. Put your pencils down. We're just going to chat for a minute, okay? And if you still need to finish copying that, we can go back to it at the end of class. So if each of the squares represents one unit, represent the number 3. So 1, 2, 3. Okay. Now they want us to add 2 more squares to it. So 1, 2. So write an expression to represent how we created a tape diagram with 5 squares. So what did we start with? 3. And then we added 2. So that's an expression of what we did. So now here is our picture. Just because they're red and blue, I just did that so we could see the 3 and the 2, but they're still constants. They all represent the same value. It doesn't mean anything different that they're different colors. So now they want us to remove 2 squares from the tape diagram. And alter our original expression to create an expression that represents what we did with the tape diagram. So we had 3, we added 2, then what did we do? Took away 2. Okay? So I wrote my new expression here, gentlemen. I wrote a new expression here to show what we did. We had 3, we added 2, we took 2 away. What did that leave me with? 3. Evaluate, remember, evaluate means to solve. So evaluate means to solve. So 3 plus 2 minus 2 equals...
Oh my gosh, no way.
Yeah, that's the wow.
So let's take a look at this picture. We had 6. 6 plus 4. So now we want to take 4 away. So 6, we added 4. We took 4 away. What were we left with? 6. So by adding, boys and girls, so by adding and then subtracting the same number of tiles resulted in the same number that we started with. Right? Who can tell me, who thinks they know, what that's called? When we go back to the same thing, we get the same number back. So I'm my own person. I can gain 10 pounds and take 10 pounds off, and I'm back to my same, what's the word? Nice, identity. Identity. What if we started with 6, we added 215, and then took away 215? What would I have left? 6. I get the same identity back. Okay? When we add one number and then subtract the same number, we get our original number. Identity. Now let's take a look at what's on the board. Now we have 2 different shapes. What do you notice about the shape W and the shape X? What do we notice? First, there's a couple things. Right, the W is bigger than the X. Is it a constant? Do we have the same value in both shapes? No. So what do I know about the W and the X?
If W is bigger than X.
They're going to be different values. The W cannot be a 1 and the X be a 1. We don't have a constant here. We have 2 different values. Now, our gut's going to want to tell us that the W is bigger, so that maybe W is 3 and X could be 2, but that's not always going to be true, so don't get caught by that. Sometimes so W could represent any number, X can represent any number, so even though the W is bigger, it's rare, but it might happen. Okay, so don't always get tricked by that. And don't always assume, well, these are about, that's about half, so it would be about half. They should be trying to draw the pictures to represent that, but it might not always be. So just be careful. Trust your math. Don't totally rely on the pictures. All right, so now let's just take a look at the equation that's here. All right, so we have a W. We have X. But then I'm going to take X away, and what am I left with? W. So this is called an identity. The number sentence is called an identity. You might want to pay attention to this homework. Because the variables can be replaced with any numbers, and the sentence will always be true. So if I made W4 and I made X2, will I get my 4 back? Yes. So we'll always get the identity no matter what numbers we choose to replace it with. Okay? Let's just jump right in and start practicing these. So on page 2, turn to page 2. On the back, use your knowledge of identities to fill in each of the blanks. So if I have 4 and I add 5, what do I have to take away to get my 4 back? If I have 4, I add 5, what do I have to take away so that I'm left with my 4? 5. If I have 25 and I take something away, but I put 10 back, and I had 25, what did I take away? 10. So I kept the same identity. What number would I have if I added 16 to it, and then took that 16 away, and I was left with 45? What did I start with? So if I have 56, and I take away 20, and I put 20 back, 56. Okay? Let's try it with variables. So if I have A, and I add B, what do I have to take away to get my A back? If I have C, and I take away D, and I put D back, what do I have to do? What do I have? If I have E, what do I have to add to it to take F away and still be left with my identity of E? What do I have if I take H away and I add H and I'm left with G? G. Questions on any of these?
No.
Your homework is the problem set on page 3. But right now, I want everybody to clear their desks and take out a dry erase board, an eraser, and a marker, and we're going to do some whiteboard exchanges.